In 2024, gold prices hit record levels, averaging around $2,386 an ounce for the year and climbing to about $2,663 in the final quarter. The surge sparked a fresh wave of interest both online and in the field. But many of the glittering finds filling TikTok feeds and YouTube shorts weren't gold at all, just convincing imposters. Sometimes it was the familiar pyrite, other times the flashier chalcopyrite, a mineral that's been tricking hopefuls since the California gold rush of 1848. The good news: prospectors have relied on a simple, reliable field test ever since, and it still works today. The new gold fever. Record prices in late 2024 pulled thousands out of their routines and into rivers, gravel bars, and garages, chasing the same glint that had defined past rushes. Gold averaged around $2,386 an ounce for the year and climbed to about $2,663 in the final quarter, sparking global headlines about its role as a safe haven. That surge coincided with both record demand and supply worldwide, and the market heat was intense enough to make amateurs try their luck. Many panned frigid creeks for hours, swirling mud in search of something bright. Others live-streamed themselves sifting through buckets of store-bought sediment under LED lights in spare rooms. Social media made it instant. One tap turned a personal find into a broadcast for thousands, archived and shared within minutes. Whether ankle-deep in slush or crouched over a plastic bin, the scene was driven by the same mix of curiosity, hope, and proof-hungry audiences. The lure wasn't just about money. A flash of metallic color taps into an almost universal reflex, the sense that you'd recognize gold the moment you saw it. Clip after clip capitalized on that. Cryptocurrency vloggers staged offline treasure hunts, lifestyle streamers added panning reels between cooking videos, and hobbyists posted first-person "I found it" stories without any background in geology. The tools and skill levels varied wildly, but the framing rarely did. Here's what I found, here's why it matters at this price. The format thrived on immediacy, and for many, the early moment of triumph mattered more than the quieter stage of testing. That same speed worked in reverse. The same platforms that spread a gold claim fed a parallel wave of fact-checks and takedowns. Within hours of a viral post, geology students pointed out that the crystals looked too sharp, mineral collectors noted how the speck moved far too easily in water, and experienced prospectors drew attention to the brassy tone of the shine. Quick side-by-side comparisons with pyrite or chalcopyrite filled comment threads, and some of the most shared clips of the rush were ultimately confirmed to show no gold at all. The tone wasn't always mocking. Many debunkers treated it as public education, but it was fast, public, and often definitive. Faced with instant correction, some creators chose transparency. A few filmed themselves testing their find using simple tools, sometimes discovering the truth with the same viewers who had cheered them on hours before. That turn from excitement to reality made for compelling footage in its own right, but not every reaction was good-humored. Some had already negotiated sales or promised a windfall to friends, and the reversal felt like a personal loss. Behind the humor and spectacle was the reminder that in a hyped market, even false hope can feel expensive. Compared to historical rushes, the modern cycle of claim and debunk runs at startling speed. Rumors that once took weeks to circle a mining camp now draw hundreds of responses before the prospector has left the stream bank. That fast feedback loop compresses the distance between discovery and disappointment, and with global gold prices so high, the stakes feel real even for small, home-based hunts. Yet despite today's abundance of tutorials and field guides, many skip verification until after they've gone live. For some, it's inexperience, for others, adrenaline. For many, it's the knowledge that a bold claim will get more immediate attention than a cautious test. The patterns echo older rushes. High prices spark migration, physical or digital, toward the promise of quick wealth, and optimism can cloud judgment. The tech is sharper, the reach wider, but the balance between gold and fool's gold hasn't changed. The prospect of proving it in front of a large audience pushes people past the point where skepticism usually kicks in. That's part of what keeps the cycle spinning. The next bright speck could either be a payday or another public correction, and either outcome draws viewers. This latest wave showed that gold fever no longer needs a tent city or a trail westward to thrive. It just needs a price chart climbing in plain sight and a platform to share the chase. The rush may look different now, but the forces behind it, market pressure, human ambition, and the thrill of recognition, are much the same. And with the rush comes the same challenge faced by prospectors a century ago, separating what's real from what just looks that way. Stick around, because next we'll look at the one simple tile test miners trusted in the 1800s, why it still works, and why Calcopyrite in particular has been outsmarting gold hunters for generations, before we step back and see how these modern surges fit into the longer story of gold rushes. The rushes never really ended. The idea of a gold rush isn't frozen in the past. It's been evolving for nearly 2 centuries, shifting from muddy campsites and pickaxes to folding tables, sluice mats, and smartphone tripods. The basic pattern remains: find material that might contain gold, work through it, and share the results. What once happened in physical camps now plays out in streaming feeds, comment threads, and hashtags, but the same drive toward a quick strike still pulls people in. The most famous example still sits at the center of the story: the 1848 discovery in California, where a single find drew tens of thousands west in hopes of a payday. That template news of discovery spreading quickly, people abandoning routines to chase it, and impromptu settlements forming near the source, shaped later rushes in places like Australia's goldfields and the Klondike in Canada's Yukon. Today, the same pattern repeats at the pace of modern communication. A single post showing a pan with flecks of yellow can reach hundreds of thousands within an hour, triggering a rush of new hands into rivers, gravel bars, or even backyards. The geography of today's gold hunt stretches far beyond one valley or range. Prospectors still head to well-known gold regions, parts of Australia, North and South America, Russia, and across West Africa, where deposits were first worked in the 19th century. Technology means even remote or previously overlooked locations can pull in new attention. A century ago, these out-of-the-way spots might have been ignored. Now they're mapped, photographed, and shared in minutes. The biggest shift comes from how people choose their ground and work it. Many modern prospectors consult historic mine records online before heading out. Lightweight, high-sensitivity metal detectors can find nuggets missed by older equipment. Drones can scan terrain that would once take days to traverse. Portable battery packs keep live broadcasts running in the field, linking a lone prospector to a worldwide audience in real time. Hydrographic maps, satellite imagery, and GPS coordinates have replaced a portion of the guesswork, lowering the barrier for newcomers. Still, some elements haven't changed at all. Whether it's shoveling gravel into a sluice, hauling buckets to a settling tub, or breaking quartz from a cliff face, the physical task of separating earth from metal hasn't gone away. A sudden glint in a pan quickens the heartbeat now, just as it did in the 1800s. And staking a claim, whether legally through permits or informally among a group of hobbyists, remains a pivotal moment in the hunt. Regulations in many regions are now tighter, with restricted zones and environmental safeguards. But the sequence of hearing about gold, deciding to go, traveling to the site, and trying your luck is the same. In Australia, public goldfields draw weekend prospectors by the dozens. Some invest in advanced metal detectors tuned for highly mineralized soils. Others arrive with more modest gear, hoping for beginner's luck. On the other side of the globe, South American rivers carry fine gold in their sediments, worked both by licensed operations with heavy machinery and by individuals gathering flakes with simple pans. Footage from these efforts, gold swirling in black pans, silt washing away from bright specks, travels easily online, inspiring searches in streams thousands of kilometers away. In West Africa, gold-bearing regions pass through families as knowledge, with specific bends in rivers or patches of soil worked for generations. Now that knowledge can be amplified instantly. A smartphone image shared within hours of recovery can draw relatives and neighbors to an area the same day. The pace at which curiosity turns into action has narrowed to almost nothing compared to the weeks or months it once took for news to travel. While some prospectors chase flakes in remote regions, others work in a decidedly urban form of gold recovery, reclaiming the metal from discarded electronics. A stripped-down motherboard might not look like a gold source, but circuit boards can yield small amounts of the metal when processed. At its heart, this is simply another way of extracting value from hidden material, one driven by the same impulse as wading into a river with a pan, even if the tools and setting are very different. Across these variations, the motivation is consistent. A significant payoff, or even the chance of one, can be enough to lure both seasoned hands and first-timers. Seeing someone else succeed, whether they're pulling a nugget from red earth in Western Australia or showing a scale tip under fine dust from a river's edge, keeps the sense of possibility alive. Information reaches further and faster now, but the underlying question hasn't changed. Will this be the day I find something real? The emotional arc is familiar too. Stories of large finds circulate quickly, sparking a scramble to the source. Within a season, yields may drop, prospects move on, and attention shifts elsewhere, but the cycle restarts with each new discovery. The instruments are more advanced, the mapping more precise, and the distribution instant, yet the fundamentals of the rush, the hope, the labor, the reveal, would be recognizable to prospectors from any era. And the similarities go deeper than behavior or technology. Gold today is still found in many of the same kinds of places it was centuries ago, shaped by the same natural conditions. Those conditions, the ones that bring real gold into reach of human hands, also tend to create minerals that only look like gold. This overlap is why impostors have always been part of gold hunting, and why the risk of mistaking one for the other is as present now as it was in the very first rushes. Why fool's gold is everywhere. Gold and fool's gold share more than just a convincing metallic sparkle. They often originate in the same physical space. The same geological process that concentrates gold can also produce lookalike minerals in the very same veins. In simple terms, first, hot mineral-rich fluids called hydrothermal fluids move through cracks in the rock. Second, as those fluids cool, the metals and sulfur they carry crystallize into solid veins that can include both gold and sulfide minerals. Geologists find pyrite and chalcopyrite near gold because they're born from the same mineral-rich fluids. Deep underground, these hydrothermal fluids form when groundwater is heated by magma or by the Earth's internal heat. The heat increases the water's capacity to dissolve and transport metals such as iron, copper, sulfur, and gold. As the fluid travels through fractures and faults, it begins to cool. Pressure drops, chemistry shifts, and the dissolved metals separate from the solution to form minerals. Sometimes this means pure gold crystals lining a crack in quartz. Other times it means sulfide minerals like pyrite or chalcopyrite growing within millimeters of that gold. Because they're all dense and metallic, they often settle side by side within the same vein. These veins don't stay buried. Over time, weathering and erosion break pieces away from the host rock. Rain, freezing and thawing, and seasonal changes loosen fragments which wash downhill into creeks and streams. Along the way, the tumbling action strips off softer material and rounds the edges of what remains. Dense minerals such as gold, pyrite, and chalcopyrite resist being swept away in fast water. Instead, they settle together wherever the current slows behind rocks, in cracks along a streambed, or in depressions in the gravel. This is where placer deposits form. A placer deposit is simply a natural concentration of heavy minerals in a riverbed or ancient stream channel, left behind after lighter sand and silt have been carried farther downstream. In historic mining areas, dry river gravels can still conceal placer deposits under layers of sediment. Scoop some material from one of these spots and you might find genuine gold flakes mixed with cubes of pyrite, both shining when they catch the sun. To the naked eye, especially in bright light, it's difficult to tell them apart without a test, and in the height of a rush, many didn't bother checking until much later. Gold-bearing regions tend to be rich in more than just gold. Areas shaped by volcanic activity, mountain building, or deep faulting are prime territory for hydrothermal circulation. Those same geological settings produce not only gold, but a range of sulfide minerals like pyrite and chalcopyrite. In some mining districts, pyrite is considered a strong indicator of nearby gold because both crystallized from the same fluid at nearly the same time. The catch is that nearby gold doesn't mean gold in your pan. It only means the conditions were right for both to form. Erosion keeps reinforcing this overlap. Picture a quartz vein shot through with gold and pyrite weathering away on a hillside. Bits of the vein break loose and roll downhill, some carrying gold, some entirely pyrite, and some hosting both. After traveling through streams, the surfaces of these fragments smooth out, their crystal edges worn away. By the time they lodge in a gravel trap, the differences between them are harder to see. Gold is heavier than pyrite, but not by a margin that would send one far downstream while the other stops. Both settle into similar traps in the riverbed. Part of pyrite's pervasiveness comes from its versatility. While gold forms under specific chemical and temperature conditions, pyrite can crystallize in a much wider variety of environments: hydrothermal veins, sedimentary layers, metamorphic rocks, even as a replacement for shell or wood in fossils. This means rivers can carry pyrite from multiple sources, whether or not any gold is present at all. In gold districts, however, its abundance and its shared formation history with gold mean it's an almost inevitable companion during prospecting. Calcopyrite follows a similar path. With copper in its composition alongside iron and sulfur, it sometimes forms in slightly different zones within a hydrothermal vein, but it's just as likely to occur in the same gold-bearing districts. Erosion releases it into waterways where, like gold and pyrite, it settles in low-energy spots along the streambed. Fresh chalcopyrite has a brassy gold sheen, but exposure to air and moisture can cause it to tarnish, producing an iridescent blue, green, or purple surface. Depending on lighting and weathering, this change can either make it stand out from gold or disguise it even further. Over centuries, this natural pairing has caused confusion for everyone from early panners working remote creeks to modern hobbyists filling buckets in backyard wash stations. A flash of yellow in the pan can trigger instant optimism, but the metal at the bottom may be a mix of substances, not all of which are valuable. In rivers and placer gravels, nature doesn't sort the real thing from the lookalikes. They drop into the same pockets and streaks of heavier material. For a prospector in a historically mineral-rich area, fool's gold isn't rare, it's an expected find. Seeing pyrite or chalcopyrite can mean you're in the right sort of deposit, but it's not proof of gold. Their similar appearance is a direct outcome of their shared origin in the way water moves dense minerals together. They're often discovered in precisely the places gold collects, which is exactly why testing matters. When two or more minerals are born together, moved together, and deposited together, visual inspection isn't enough to tell them apart reliably. That's the practical consequence of all this geology. Without a field test, the risk of confusion is high. The streak test, rubbing a specimen across unglazed tile to check the color of the powder it leaves, remains one of the simplest ways to separate genuine gold from these heavy sulfides. Understanding how gold and its impostors form and travel makes it clear why they end up side by side in a pan, and why the difference can't be trusted to sight alone. So which of these imposters is easiest to spot, and which one will actively trick you? Spoiler, one won't, it'll crumble under a pin. Meet Chalcopyrite, Pyrite's flashier cousin. Among gold lookalikes, Pyrite gets most of the attention, but there's another contender that often proves more deceptive in the field, Calcopyrite. While Pyrite's sharp cubic crystals can betray it to a practiced eye, Calcopyrite tends to appear in less obvious shapes that give fewer visual clues. In the right light, and especially to someone relying on quick judgments, it can match gold's color and texture closely enough to sway a hopeful prospector. In a river, pan, or sluice, that subtle resemblance can be persuasive until a proper test is done. Calcopyrite is a copper-iron sulfide combining copper, iron, and sulfur in its structure. That extra copper changes the way it reflects light, giving fresh specimens a slightly deeper, warmer brassy tone than pyrite. Real gold maintains a constant metallic yellow under nearly all conditions, but in unweathered Chalcopyrite the hue can be close enough to cause hesitation. Fragments tumbled by water or freshly broken from a vein sometimes take on a glow in sunlight that looks, in the moment, much like fine gold dust or small nuggets. In nature, Chalcopyrite occurs in quartz veins or as massive metallic material without the neat, repeating crystal shapes typical of pyrite. Its grains and tetrahedron-like forms are less likely to jump out as mineral rather than metal. That absence of obvious geometry makes it harder to dismiss at a glance. Where pyrite might reveal itself by symmetry, Chalcopyrite's irregular surfaces can mimic the rounded or worn edges people associate with alluvial gold. Exposure to air and moisture brings oxidation into play. Chalcopyrite can tarnish into vivid blues, greens, and purples, the peacock ore effect. That level of iridescence is an easy giveaway because gold never does this naturally, but partial oxidation can produce a more muted warm brown or orange-gold surface with only faint color shifts near the edges. In variable outdoor light, that subtle change can blend right back into the range of tones a prospector expects from gold in a pan. That's why lighting and angle matter so much during visual identification. Calcopyrite also behaves in ways that can mislead during quick field tests. On the Mohs hardness scale, it ranks around 3.5 to 4. Gold is softer, about 2.5 to 3, and pyrite is significantly harder, 6 to 6.5. This places Calcopyrite closer to gold than pyrite in terms of hardness. A casual soft equals gold field check, pressing with a copper coin or knife, may still leave a mark on Calcopyrite, giving the impression of softness without revealing that it's actually a little harder than gold. This overlap can confuse those relying solely on scratch resistance as proof of authenticity. Occasionally, Calcopyrite will deform slightly under firm pressure, though not with the same pliability as pure gold. Detecting that distinction requires attentive comparison, a step often skipped when excitement runs high. In the field with only a moment to judge, the line between malleable and just soft enough can be hard to draw. That's why experienced prospectors advocate combining hardness checks with other tests, particularly the streak test. If you see metallic yellow that indents with a coin and shows a warm tone, don't celebrate, do the streak test next. Density is another factor in its ability to fool. Gold's density is about 19.3 g/cm3, Calcopyrite S around 4.143. Though much lighter than gold, Calcopyrite is still heavier than quartz, mica, and other common sediment minerals. In flowing water, it concentrates in the same low-pressure zones, the pockets behind rocks, the cracks in bedrock where gold settles. In a pan, flakes of Calcopyrite can remain while lighter material washes away, leading to the same behavioral cue gold gives. Without weighing it or using a density test, it's easy to mistake that persistence in the pan for evidence of high value. This collocation happens frequently in gold-rich areas. A prospector may pull both gold and Calcopyrite from the same deposit, their differing values only revealed later back at camp or during lab analysis. The mingling of the two strengthens Calcopyrite's reputation as a deceiver. It's not just how it looks, but where and how it shows up that convinces people they've struck something valuable. Its name derives from Greek words for copper and fire, reflecting both appearance and industrial role. Calcopyrite is the world's most important copper ore, mined extensively for that metal. For small-scale gold hunters, finding it might not mean a worthless pan. The mineral itself has economic value, but outside of copper mining, its worth is far less than an equivalent mass of gold. The difference between pyrite and Calcopyrite in this context is almost like the difference between a crude forgery and a skilled counterfeit. Pyrite's geometry and greater hardness give it away with the right checks, but Calcopyrite adjusts its presentation depending on conditions. Sometimes smooth, sometimes tarnished, sometimes showing a glow that matches gold's warmth. It adapts enough to exploit the shortcuts people take when identifying minerals in the field. This adaptability is why so many prospectors keep a mental note about Calcopyrite once they've encountered it. You can train someone to reject pyrite by its cubes and hardness, only to have Calcopyrite bypass those defenses. It isn't as well known in popular imagery, making it an unexpected stumbling block. The second test many don't realize they'll need. Streaking it against unglazed tile will produce a blackish green mark rather than gold's yellow, and measuring its density will confirm the difference. But by the time those careful checks happen, the initial thrill of discovery has often already taken hold. That moment of early certainty is why Calcopyrite earns a place in so many prospecting stories. The gap between seeing it in the pan and learning the truth can be hours or days, and in that time hope builds. Whether gathered from a riverbed bend or chipped out from a quartz seam, its convincing resemblance, behavior in water, and misleading softness make it a persistent hazard for anyone chasing gold. And for every prospector who shrugs off a mistake, there's another who remembers exactly where they were when they realized their find wasn't what they thought. That emotional imprint means Calcopyrite is more than just a geological fact, it's part of the shared experience of gold hunting. Stories circulate in clubs and online forums about the time I got fooled, often accompanied by close-up photos showing just how convincing it looked. These accounts keep the warning alive across generations of prospectors. Being able to spot pyrite isn't enough because something subtler can still pass through your defenses. From riverbanks to mine tailings, Chalcopyrite's role as copper ore and its mimicry of gold give it a dual identity, economically relevant in one industry, misleading in another. Knowing its properties from its tarnish patterns to its hardness range keeps the odds in your favor. For those working where gold and Chalcopyrite coexist, the takeaway is simple: never rely on a single visual or tactile check. Use the streak test, note the weight, and remember that appearance in the pan is only the first step toward knowing what you really have. As plenty of modern and historic prospectors have found, that first impression can be costly. The combination of geological overlap, visual similarity, and behavior in the pan creates fertile ground for mistakes that feel convincing until the evidence says otherwise. And in public settings, those mistakes can carry an extra sting, because when a misidentification happens in front of an audience, the lesson quickly stops being private. Some mistakes in gold hunting have earned a lasting place in prospecting lore, vivid reminders that the human eye can be remarkably easy to fool. This unofficial misidentification Hall of Fame spans centuries, from early explorers to backyard panners, each case built on the same sequence of discovery, confidence, and the moment the truth arrives. One recent, much-shared example began with a hobbyist broadcasting a weekend creek trip to an online audience. They laid out several bright, weighty chunks from a jar, angling them toward the camera so every facet caught the light. Chat messages poured in, and in that atmosphere of excitement, someone floated a generous offer to buy the lot. A meeting was discussed almost immediately. But before the trade could happen, the would-be buyer produced a simple ceramic tile and dragged one of the pieces across it. The mark left behind was not gold's yellow streak but a dark greenish-black. The room fell quiet, and without another word, the deal dissolved. What had looked on screen like a windfall was quickly identified as pyrite or chalcopyrite. Viewers had seen the swing from certainty to disbelief inside a minute, and the clip circulated widely as a blunt lesson: test before you sell. These reversals are hardly a modern invention. In the mid-1500s, even French explorer Jacques Cartier mistook glittering iron pyrite and quartz collected in what is now Canada for gold. Historical accounts describe how he brought his treasure back to France, only for it to be dismissed by experts as worthless. 300 years later, in the frenzy of the California gold rush, seasoned miners told of men filling sacks over weeks with coarse yellow flakes, convinced they were sitting on a fortune. When their haul reached an assay, they were told it was nothing more than iron sulfide. Some spotted the cubic crystal forms early and broke the news on sight. Others only learned the truth after hauling their heavy but valueless cargo to town. Australia's Victorian goldfields saw similar episodes. Entire teams would work a rock face that had revealed a brassy shimmer at dawn, returning day after day to hammer out more. The ore carried home looked promising under low light, but when samples were tested at government assay offices, the supposed gold vein proved to be overwhelmingly chalcopyrite, offering no recoverable gold. The copper content had lent the right kind of luster, while the mineral's rough, irregular patches had imitated the texture the miners expected from massed gold. The late 19th century Klondike gold rush brought its own share of misplaced confidence. Prospectors hauling material from icy streams were sometimes convinced they had found gold based on color alone, only to discover months later in Dawson City that their pan concentrate was rich in pyrite. In those conditions, with long travel times and harsh weather, hope could outweigh doubt, and many clung to their certainty until official tests erased it. Even well into the modern era, high-profile events have demonstrated how large the gap can be between appearance and reality. The Bre-X Scandal of the 1990s remains one of the most infamous. A mining company's claims of a massive gold deposit in Indonesia proved to be based on salted samples, triggering one of the industry's largest frauds. Though this involved deliberate deception rather than an honest mistake in the field, its exposure depended on the same core truth. Visual impressions and early assays aren't proof until they've been systematically verified. What links these cases, whether centuries past or within the last year, is the way optimism shapes perception. A shiny yellow surface triggers a chain of thoughts about value and possibility, often before the finder applies any test. That first conclusion, "this is gold," becomes the lens through which all later evidence is viewed. Under that influence, a streak color that doesn't quite match or a hardness result that feels off can be rationalized away. The more anticipation and attention surrounding the find, the greater the temptation to skip confirmation. Public exposure changes how the moment plays out, but not the arc itself. In the 1800s, a prospector might discover their mistake in front of a few fellow miners at camp. Now, an online post can reach thousands before correction lands minutes later in the comments. For some, that speed brings useful feedback. For others, it amplifies embarrassment, preserving the proof of the error alongside the initial claim. In both eras, these stories spread fast, not only because they're cautionary, but because the turn from hope to reversal is so stark. Such anecdotes endure in part because they touch on something every prospector understands: the desire for your effort to pay off. Whether someone has spent months cutting a shaft into permafrost or an afternoon crouched at a backyard tub, that early rush of seeing potential gold feels unshakable. When that's stripped away by a single test, the disappointment cuts deep and the memory sticks. Seasoned miners and casual hobbyists alike repeat these misidentification tales to newcomers as warnings. They underline a reality of geology. Gold rarely travels alone, and its most convincing imitators often arrive under the same conditions, settling into the exact places a search will focus on. Shared habitat, similar density, and the accident of light on metallic surfaces make for convincing but false matches. Without a step beyond visual inspection, the odds of error stay uncomfortably high for everyone, no matter their experience. Reactions to these mistakes vary. In older accounts, some prospectors relished catching the error in others, seeing it as evidence of their own skill. Others told self-deprecating stories about the time they themselves filled a pack with fool's gold, treating it as a rite of passage. Modern audiences show the same spectrum: criticism, sympathy, and the sharing of similar near misses, often intended to take the edge off for the person whose mistake is on display. The key to avoiding a place in this unofficial Hall of Fame lies in having a reliable way to confirm what your eyes are telling you, especially when the find is fresh and the temptation to believe is strong. Hope has undone some of the most confident prospectors in history, from Cartier's ill-fated voyage to 19th-century mining camps and today's digital broadcasts. Visual match alone isn't enough, and simple tools can protect both your pocket and your pride. Want a field test that avoids that public humiliation? It's what prospectors have trusted for 175+ years, and it's insanely simple. Field testing without fancy gear. When you're on site far from any lab or chemical kit, the first challenge isn't figuring out how to store a glittering fragment, it's deciding whether it's worth carrying back at all. Bright reflections in sunlight, a metallic glint in a pan, even reassuring heft in your hand can feel convincing, but those impressions are often misleading. Experienced prospectors know that looks can fill pockets with worthless rock. Without tools like spectrometers or acid tests, the simplest, most portable option becomes your best ally: a basic streak test you can do anywhere. Think of it as a 3-step field check that works with little more than what fits in your pocket. Step 1, make sure you have an unglazed ceramic surface. This could be a small streak plate, the back of a plain tile, or even a scrap of unglazed porcelain. It works because its hardness is about 7 on the Mohs scale. Softer minerals will leave a powder mark, harder ones generally won't. If your specimen skates across without a trace, it's probably too hard to give a meaningful streak and will need a different test. Step 2, place the tile on a firm surface and drag the specimen across it with steady pressure, in much the same way you'd use a crayon. The goal is to leave a trail of powdered mineral behind. If you're working with a small flake, position it carefully and use a short, controlled stroke to avoid losing it. Breaking a sample to expose a fresh, unweathered surface before streaking can make the result more reliable, since tarnish and oxidation can mask the true color. Step 3, read the result in good, even light. Gold produces a clear, metallic, golden-yellow streak that retains its richness even as a fine powder. Pyrite leaves a dark greenish-black line, often with no metallic shine when viewed up close. Calcopyrite also produces a green-black mark, sometimes with a slight color variation due to its copper content. These telltale streak colors cut through surface appearances instantly, showing you what the mineral is made of rather than how it happens to look in the moment. The strength of this test is that it bypasses the unreliable cues of surface reflection. Small changes in light, weathering, or impurities can make pyrite or chalcopyrite appear almost identical to gold in the pan. Once reduced to powder, those illusions disappear. You're no longer judging shine on a crystal face, you're seeing the unpolished, consistent color of the mineral's base composition. Another benefit is that it doesn't require specialty skill to interpret. Where identifying a mineral's crystal form or estimating hardness can demand experience, the streak test reduces the decision to a simple color check. For gold, there's no ambiguity. Either you see golden yellow or you don't. Practice with known samples before heading into the field will lock those reference points in your memory and make on-site judgments faster. You also don't need a large sample. With care, even specks or tiny chips can yield a usable streak. This is important in placer mining, where the most common finds are flakes and small fragments. Testing immediately means you can keep working only in productive spots instead of processing buckets of material for minerals that look right but aren't gold. Because the tool is just a small square or shard of unglazed ceramic, it's easy to carry and nearly impossible to break accidentally. Many prospectors keep one in a field kit next to their pan or shovel. Unlike a hardness pick set or battery-powered gear, it needs no calibration or upkeep, and it works the same whether it's dry, wet, or covered in grit. Lighting conditions have little influence on the outcome. In shaded creeks at dusk or under harsh glare, metallic colors can shift dramatically to the human eye, leading you toward incorrect calls. The streak's powdered form reflects light differently and retains its true color regardless of where or when you test it, giving consistent results at times when visual inspection alone might mislead you. It's worth noting that the streak test isn't a replacement for more thorough verification, it's a first-line filter. If the streak shows the real golden yellow, that's the point to set aside the sample for further analysis. If the streak is dark, you can confidently move on without spending more resources. This approach saves time and effort, letting you focus heavier-duty tests like lab assays or portable XRF scans on material with a shot at being valuable. Historically, miners adapted whatever they could find for this purpose. In the 1800s, isolated camps would break shards from porcelain dishes or use the bottoms of clay mugs when no tile was handy. The principle hasn't changed since then, even as field kits have improved. Whether in the Yukon, Victoria, or a small backyard claim, the streak test remains a direct way to separate ore worth pursuing from a pile of fool's gold. In modern prospecting, this simplicity is an asset. You could carry advanced instruments into the field, but those devices take time, battery power, and careful handling. A tile fits in your pack without thought, takes seconds to use, and immediately clears away doubt for most common imposters. For working prospectors, that speed and lack of fuss often matters more than high-resolution data that's impossible to act on until you're home. If you're new to prospecting, it's worth running streak tests on a variety of minerals before your first serious trip. Using labeled samples of gold, pyrite, chalcopyrite, and similar materials under controlled conditions will anchor your sense of what each streak color looks like. That way, when you're standing knee-deep in a river with light fading, you'll make quick, solid calls that keep you from filling a pack with valueless rock. Weigh, scratch, look under magnification, all these are useful steps in mineral ID, but streak testing stands apart for how little guesswork it involves once you know the signals. When performed right, it won't damage most specimens and will give you a consistent reading even on irregular shapes. Combined with context, knowing the kind of deposit you're working, it forms the basis of a reliable on-site decision. And while no single low-tech method can cover every case, the streak test consistency is why so many seasoned hands still regard it as essential. It compresses dozens of visual impressions into a single, repeatable result you can trust across different locations and lighting. Done regularly, it sharpens your eye for differences that might otherwise go unnoticed and keeps your energy focused where it counts. Once you've mastered the method and can produce a good streak, what you see on that tile becomes the deciding factor for what comes home with you. It's that mark, not the shine in the pan, that tells you whether you're looking at something valuable or another member of the fool's gold family. And that's where understanding exactly what those streak colors mean starts to matter. Reading the colors in the streak. Reading the color of a streak on unglazed ceramic is the quickest way to separate gold from its most convincing mimics. Once you know the signals, it becomes a straightforward comparison you can recall instantly. Think of it as a simple rule of thumb. Gold leaves a metallic golden yellow streak. Pyrite leaves a greenish black or brownish black streak. Calcopyrite leaves a green black streak that can carry a faint brown tint. Gold equals gold streak. Everything else in this specific test comes back dark. When you get a true gold streak, the powdered line matches the tone of the nugget or flake in your hand, only scattered into fine grains. There's no dullness, no shift toward another color, no hint of gray or green. That's because pure gold has no mineral coating or structural quirk to distort its true hue. Whether you drag a small flake or a larger piece, the result is always that unmistakable metallic yellow, consistent from one sample to the next. Pyrite can rival gold for visual flash in a pan or streambed, but once powdered, it shows itself. On ceramic, it leaves a greenish-black line, sometimes skewing toward dark olive or brownish-black depending on trace elements and the exact conditions in which it formed. Without magnification, the powder looks flat and non-metallic compared to gold's brightness. This is iron sulfide revealing its real identity. The brassy light you see in a solid face is an effect of crystal structure and light reflection, not the inherent color of the mineral. Calcopyrite's streak is similar but not identical. The copper in its makeup can pull the powder toward a green-black with a muted brownish undertone. Freshly broken pieces can fool the eye far more effectively than pyrite, but the streak never holds onto the rich yellow of gold. It dulls out immediately into its base color. That's the strength of this test. Powdered form ignores the tricks that surface reflection plays on your perception. Because streak color comes from the powdered mineral, it is not affected by surface tarnish, water, or lighting conditions. This makes the test highly reliable in situations where appearance changes quickly, shaded creeks, overcast days, or after a mineral has been submerged. Even so, one practical habit boosts accuracy: always dry and clean your sample before testing. A thin layer of mud, oxidation, or algae can smear across the plate and alter your first impression, especially with smaller flakes. A quick rinse and dry removes that risk. The act of streaking is simple. Hold the sample firmly, drag it across the unglazed ceramic in a short, steady motion, and compare the result immediately with your mental reference. You're looking for that clear golden yellow and gold in those darker, earthier tones in its imitations. A gentle pass is all that's required. You don't need to grind down the piece, just leave enough powder to read the color. Purpose-made streak plates are inexpensive and widely available, but any unglazed ceramic will do. The back of a tile, a scrap of porcelain, or a piece of unglazed dinnerware can all stand in. The key is that the surface be uncoated so the powder sits on top rather than smearing into a glaze. In field kits, many prospectors carry a small tile shard wrapped in cloth or plastic to protect it and prevent stray powder from rubbing off in the pack. At home, a streak plate lets you process large batches of specimens quickly. A row of lines on a single plate, gold beside pyrite, chalcopyrite, and other collected minerals, becomes a visual reference library you create yourself. The ability to compare them side by side reinforces the differences until you can spot them almost by instinct. This hands-on record is often more useful than printed charts because it matches the exact conditions of your own testing. Speed is a major advantage. Without the streak test, visual sorting depends on moving samples into the best light and tilting them to judge reflectivity. That's subjective and prone to hopeful bias. The streak test turns the decision into a binary choice. Does it leave the golden streak or doesn't it? In the field, this decisiveness keeps you working productive spots and reduces the amount of worthless material you carry home. The permanence of the streak also matters. Once on the plate, the line remains for days or longer, allowing repeated checks or side-by-side comparison. In training, some prospectors deliberately apply streaks from both genuine gold and known fool's gold, then revisit the plate after a week. Seeing that the colors don't shift over time bolsters confidence in the method. Small details make the process more consistent. Breaking a specimen to expose a fresh surface before testing avoids the influence of weathered rinds or oxidation films. Using moderate pressure helps ensure you're getting powder from the core rather than just brushing the surface. Wiping the plate clean between tests prevents powder from earlier samples contaminating the next result. These habits don't take long to build and quickly become automatic. For new prospectors, the streak test is often a turning point. After a few rounds of seeing pyrite's dark streak or chalcopyrite's green-black, the idea that these minerals could be gold starts to lose its hold. Confidence grows not just in spotting the real thing, but in rejecting the lookalikes without regret. In difficult conditions, cold water, low light, end-of-day fatigue, that certainty keeps your judgment sharper. Even for those with years of experience, the test remains a checkpoint. A flash in the pan can raise anyone's pulse, but putting it across ceramic brings the answer before imagination takes over. In that sense, the streak plate works as much against your own optimism as it does against the mineral's camouflage. Over time, the speed of reading streak colors becomes second nature. The motion of the test, the check of powder, and the decision to keep or discard all happen in seconds. This efficiency makes it easy to integrate into every stage of prospecting, from first pan to final home sorting. It also spares you the frustration of discovering a mistake after hauling and cataloging unusable rock. When judged purely against gold's market value, fool's gold earns its name for how often it has misled miners and hobbyists alike. But away from the pan and the streak plate, these minerals are not without merit. What they lack in precious metal price, they can make up for in entirely different kinds of value, and in the right setting, that value is substantial. When fool's gold pays off. Pyrite and chalcopyrite may frustrate gold hunters in the moment, but outside the prospector's pan, they have long been sought for reasons that have nothing to do with fooling anyone. In the wider mining world, these minerals are not troublemakers but valuable ores, forming the backbone of industries that keep modern systems running. So that fake gold could still be the backbone of industries worth billions, a different kind of treasure. Their deceptive shine is almost incidental compared to the metals and chemicals they contain, which are essential in construction, manufacturing, agriculture, and technology. Calcopyrite is a prime example. As a copper-iron sulfide, it is the main ore of copper in many deposits worldwide. Inside its brassy metallic grains is enough copper to make it worth extracting on an industrial scale. Copper is in high demand because it conducts electricity efficiently, resists corrosion, and can be formed into thin wires or sturdy pipes. It runs through buildings in electrical wiring, carries voice and data across telecom networks, and forms the circuitry that keeps computers, vehicles, and smartphones functioning. In many mines, chalcopyrite is not an incidental find. It is the primary target, with any gold recovered during copper processing treated as a profitable extra. Turning chalcopyrite into usable copper involves a series of well-established steps. The ore is crushed to liberate the minerals, then concentrated often by froth flotation so that the copper-bearing fraction can be separated from surrounding rock. Smelting follows, heating the concentrate at high temperatures to drive off sulfur as gas and leave behind a molten copper-rich material. Refining takes this further, producing copper pure enough for precise applications like electrical cabling. This same pipeline supplies the copper in household plumbing, high-voltage transmission lines, printed circuit boards, and the wiring inside renewable energy infrastructure such as wind turbines and solar arrays. The same mineral that fooled a prospector in a creek might, in another context, become part of the wiring in a city's power grid. Pyrite has a different economic role. While it is not mined primarily as an iron source, that role falls to hematite and magnetite. Its sulfur content makes it commercially useful. For much of industrial history, pyrite was a leading raw material for producing sulfur compounds, especially sulfuric acid. Today, sulfuric acid remains one of the most important industrial chemicals in the world. It is a key reagent in turning phosphate rock into soluble fertilizers, enabling agriculture to meet global food demands. It is also used in petroleum refining, wastewater treatment, and countless chemical synthesis processes. Processing pyrite for sulfur involves roasting it in air to produce sulfur dioxide gas. This gas is then converted to sulfur trioxide over a catalyst and combined with water to form sulfuric acid. In regions where elemental sulfur from oil and gas refining is less available, pyrite can be an important feedstock for this sequence. An outcrop rich in pyrite might therefore be far more valuable to a chemical plant than a gold vein of similar size is to a jeweler. The gleaming cubes that signal disappointment to a gold prospector can, in the right hands, become ton after ton of chemical building blocks for global industries. These industrial roles also play out in complex ore bodies. In some massive sulfide deposits, chalcopyrite and pyrite occur together alongside other base metal minerals such as sphalerite for zinc. Mines in these settings often design their processing flow to recover multiple products: copper from chalcopyrite, zinc from sphalerite, and sulfur from pyrite. Gold, if present, is often the secondary consideration, and its value simply helps offset operational costs. Seen from this angle, the same pan concentrate a hobbyist might discard after a streak test could be the focus of an operation designed to keep smelters and refineries supplied year-round. The contrast in perspective is stark. In small-scale prospecting, pyrite and chalcopyrite are false leads that waste time. In industrial mining, they can be the chief reason for digging. The cubic pyrite crystals set aside in a pan might be exactly what a sulfuric acid plant wants by the railcar load. The brassy masses of chalcopyrite a prospector drops back into the creek could be the ore feeding a copper smelter that supplies electrical cable manufacturers. Where one sees an obstacle, the other sees a resource. This reversal of value is reinforced by market demand. Gold's appeal is partly in its rarity and associations with wealth, but its industrial uses, while important, are limited in scale. Copper, on the other hand, is consumed globally in volumes that exceed millions of tons per year. Sulfuric acid's consumption is similarly vast, and the processes to make it from pyrite are well proven. That consistent demand means these minerals are actively explored for and extracted in their own right, regardless of any precious metal content. Understanding these uses reshapes how finds are evaluated. For geologists, spotting chalcopyrite in a core sample signals potential copper reserves. Pyrite in sufficient concentrations may mark sulfur resources worth exploiting. Even if you have no means to mine or refine them yourself, knowing their roles explains why certain regions see constant commercial activity even without rich gold veins. Mining economics run on what can be processed and sold in bulk, not on immediate visual appeal. In that light, the phrase "fool's gold" is incomplete. It describes the letdown of mistaking these minerals for gold, but ignores the substantial economic role they play. In some contexts, overlooking them is the real error. A deposit low in gold but rich in chalcopyrite can underpin decades of copper production. A pyrite-rich ore body can anchor a sulfuric acid supply chain feeding agriculture across entire regions. For commercial miners, the gold in fool's gold is metaphorical. It lies in marketable output, not metallic color. This wider view also places small-scale prospecting in perspective. A lone panner without smelting facilities will not benefit directly from a bag of chalcopyrite-rich gravel. But at larger scales, with the processing capacity to extract copper or sulfur, those same stones are the heart of the operation. That's why in mining districts, corporate exploration teams map and sample for these minerals with as much focus as independent hunters reserve for tracking placer gold. It is also a reminder that value is defined by use. Chalcopyrite supports the electrical systems that power cities and devices. Pyrite contributes to the chemical processes that underpin agriculture and manufacturing. They may not make headlines as often as gold strikes, but their economic footprint is broader and in some sectors indispensable. Recognizing the worth of these lookalike minerals also changes fieldwork priorities. Even if your goal is recreational gold, recording where you see significant pyrite or chalcopyrite can help build a useful picture of the geology. In historical mining regions, these minerals often marked economically viable deposits long before modern surveying tools expanded the search. That alignment between past and present prospecting targets hints at how mineral value has always been linked to technological and industrial needs. From the prospector's viewpoint, none of this changes the fact that in the moment, pyrite and chalcopyrite are not the prize they set out to find. But it does show that worthless is a relative term. In the right context, they are not impostors at all, they are the main event. Recognizing that dual identity adds another layer to mineral identification, the knowledge that the same sample could be either a discard or a cornerstone, depending on whose hands it's in. That awareness matters more now as the tools for finding and testing minerals evolve rapidly. The same shift in perspective that can turn a so-called false lead into a core commodity also invites a broader approach to identification, one that blends hard-won field skills with the precision of modern analysis. Modern foolproofing, tech versus tricksters. By the mid-2020s, prospecting often begins with more than a pan or pick in hand. Increasingly, hunters turn up outfitted with gear that promises to analyze finds on the spot. Portable X-ray fluorescence (XRF) units, once confined to labs and industrial sites, are now small enough to ride in a backpack. Paired with a battery pack, they can scan a specimen and deliver its elemental breakdown in seconds. Alongside them, smartphone-based spectrometry attachments have found use with weekend panners, connecting to a phone camera and an app to produce a quick spectral signature. In theory, that means no more guessing, just point, press, and know. Paper, it looks decisive. Pick up a promising fragment, aim the scanner, press the button, and get a chart showing gold, copper, iron, or whatever else is present. Both tools deliver this kind of data far faster than a traditional assay, cutting the waiting time from weeks to moments. That speed appeals on cold riverbanks or steep tailings piles, where every extra trip hauls weight you may otherwise leave behind. It can feel like carrying a condensed version of a professional lab anywhere you go. But these tools have limits. XRF works by firing X-rays into the material and reading the energies of the secondary radiation that bounces back, which identifies the elements present. If the surface isn't cleaned, if mud, oxidation, algae, or other coatings remain, the reading can be skewed. Angle and distance matter too. Uneven surfaces can scatter the signal, producing misleading results. Smartphone-based spectrometers face the same challenge in different form. They rely on consistent light and clean, sharp images. Bright glare off water, deep shadow, or even the way light hits a rough surface can shift the recorded spectrum. Both can still produce a confident-looking output even when the conditions are wrong for accuracy. That's led to a new kind of false positive, not mistaking pyrite for gold by sight, but believing an instrument over what's actually in the rock. Cases circulate where a handheld unit reported a measurable percentage of gold, convincing the user they had something valuable, only for a laboratory assay to reveal there was none. Sometimes, the device detected trace contamination on the surface rather than anything in the bulk. Other times, it averaged the composition over too small a patch to represent the whole. The reading was real for that tiny spot, but irrelevant to the wider sample. Modern prospecting often favors speed, scan, decide, move on. But without taking multiple readings on different faces or breaking a specimen to get a clean interior surface, it's easy to be misled. That's why seasoned hands repeat scans, compare spots, and look for consistency before trusting any one result. And above all, they avoid switching off other simple, proven checks just because a screen gave them a number. A clear rule of thumb has emerged among those who blend both approaches well: streak first, tech second. Run a sample over an unglazed tile before you ever put it under a battery-powered lens or sensor. The streak test ignores lighting, surface coatings, and software quirks. If it shows the golden yellow line that only gold leaves, then it's worth the extra battery to follow up. If the streak is dark, don't waste time or power, move on. This sequence filters out a large proportion of false hopes before you even open the gadget case, and means confirmed rejects never eat into your device's operational life. Even large-scale operations use similar layering. XRF and spectrometry help map mineral distribution and highlight promising targets, but they are not the final word. In mining, confirmation still comes from fire assay, a slower process that physically extracts and measures gold. That principle holds at smaller scales. The streak test guides your attention, portable tools add deeper clues, and if a find still looks good, an assay closes the case. Each acts as a stage, not a substitute for the others. This layered workflow avoids one of the main traps in high-tech prospecting: the bias to treat the latest reading as the truth. Technology adds speed and precision in good conditions, but poor handling or environmental noise can create believable mistakes. The infamous Bre-X mining scandal of the 1990s, while involving deliberate fraud, still illustrates how assays and instruments can present convincing proof that later collapses under rigorous testing. In that case, salted samples fooled investors and experts for years, until proper verification revealed the absence of gold. The scale may differ, but the message is directly relevant. Without independent confirmation, even the most compelling dataset can be wrong. For small-scale prospectors, keeping the tile in play does more than save battery. It builds a deliberate pause into what can otherwise become a rapid cycle of scanning and moving. The test requires no calibration, ignores mud and weather, and can survive a fall into the water without losing function. It's cheap, replaceable, and works anywhere. In difficult terrain, where carrying sensitive electronics is a risk in itself, that kind of reliability is not just a backup, it's part of the primary toolkit. There's also the matter of attention. Looking at a color line on ceramic puts you in direct contact with the evidence without layers of software interpreting it for you. It can slow the rush of judgment, especially if you're working in front of an audience or with the pressure of time. You're working with a physical property you can verify with your own senses, rather than relying solely on mediated feedback. That shift in pace can make the difference between catching a mistake early and building a plan on flawed data. Plenty of recent missteps documented online had little to do with pyrites or chalcopyrite surface tricks, and everything to do with reading too much into a hasty scan. In some, a single percentage figure from a device was enough for a declaration of discovery. Only later, sometimes hours, sometimes weeks, did a lab assay or simple field test undermine it. The optics of those reversals are worse when the overlooked step could be done in seconds with a tile you already own. None of this means setting advanced tools aside. Portable XRF and spectrometry can detect traces invisible to the eye, highlight mineral associations worth following, and help build a picture of an area's geology faster than traditional prospecting alone. They can reveal fine-grained mineralization hidden in rock that appears blank, or signal other metals with market value in the same deposit. Used in the right sequence, they expand what a single prospector can achieve in a day. The key is balance. Recognize the limits of each stage. A streak test sorts quickly and weeds out most fool's gold. Portable tools deepen the investigation of what passes. The lab confirms the final truth. Ignoring any one stage raises the odds that you'll carry, process, or post about material that doesn't deserve it. Maintaining all three steps in order is how experienced prospectors avoid becoming the subject of someone else's cautionary video. This approach doesn't just conserve resources, it preserves credibility. A public claim backed by multiple checks has more weight than one built solely on an on-screen reading. And in an age where every find can be broadcast immediately, that credibility can matter as much as the find itself. That's because the challenge in prospecting isn't only about identifying what's in your pan or sample bag. The human factor plays an equally strong role, and the most sophisticated workflow can still be undermined by the way we respond to that first glint. The psychology of being fooled. When a bright yellow glint appears in a pan or in rough rock, the mind often reacts before the hands or tools do. The first thought isn't about verification, it's about possibility. That leap is a textbook case of confirmation bias, the instinct to interpret what you see in a way that reinforces what you were already hoping for. If the day has been spent thinking about gold and a speck fits that picture, the brain leans into the gold explanation without waiting for evidence. In the field, this can take root almost instantly. Hours of sifting gravel, scanning with a detector, or hauling sediment sets a stage of expectation. Fatigue and effort build the desire for a payoff. When something metallic shows up, the context favors belief over doubt, even if experience says pyrite and chalcopyrite are common in the same conditions. The circumstances, long work, scarce results, sudden visual reward push perception toward the conclusion you want instead of the one that's most likely. That gear shift changes more than your mood. The rush of thinking you've made a find narrows focus onto details that seem to confirm it. The gleam in a certain light, the apparent weight in the hand, the fact it turned up in a location known for past gold recovery. Those exact points could belong equally to fool's gold, but the excitement edges out that possibility. Even seasoned prospectors can drift into this state, forgetting planned checks or delaying them in favor of showing the piece around first. Modern prospecting adds another influence, the pull of sharing a discovery. With a phone in your pocket, the option to turn a find into content is immediate. Posting a quick photo or video brings instant attention and feedback, which can feel like part of the win. But as soon as a possible find is made public, the initial idea gains momentum. The public framing of "this is gold" makes it harder to consider alternatives openly, and the thought of correcting yourself later can become another reason to postpone testing. Those extra layers of attention, even from just a few contacts or followers, can increase the reluctance to introduce doubt. Some people keep a find untested for hours or days simply to preserve the sense of potential and avoid having to change the story they've already started telling. The longer that gap stretches between seeing the shine and checking its identity, the stronger the attachment becomes, which makes any reversal sharper. The solution isn't to strip away the enjoyment of prospecting, but to recognize where judgment can tilt under pressure. Confirmation bias works best when conditions are tiring, results are rare, and the desire for a positive outcome is strongest. Prospecting provides all three. Building in small habits that counter that influence makes it easier to keep decisions clear. 2 field-friendly rules can help. The first, delay the post. Give yourself a pause between discovery and any form of broadcast, whether that's a short video or a photo in a group chat. Run a streak test or other reliable check first so that what you share begins from fact, not assumption. You keep control of the narrative, and if the result isn't gold, you avoid having to retract a public claim. The second, test in stages. Instead of checking each shiny piece as it appears, drop every likely candidate into one container as you work. When you reach a natural break, run streak tests on the full batch together. This keeps you from breaking focus or rushing each individual test, and you can compare results side by side under the same light. In practice, that method catches more false positives and keeps the high of a genuine find clearer, because you'll see its unmistakable streak next to the darker marks of the lookalikes. Both rules hinge on breaking the chain between first impression and final conclusion. They create room for cooler evaluation, lower the chance of carrying or posting fool's gold, and make your workflow less dependent on how you feel in a single moment. They also make the act of testing a regular, unskippable step rather than something you do only when you remember. Awareness of why these habits matter is the bridge between knowing and doing. Prospecting is rarely quick or easy, and the scarcity of real gold makes each possible find stand out in memory. The pull toward believing can be strong enough to override what you've already learned about imposters. Putting process ahead of declaration safeguards both your accuracy and your motivation to keep going when a sample fails. These small disciplines also act as insurance for your standing with others. In a world where mistakes can be replayed indefinitely, avoiding unnecessary corrections protects not just the timeline of your search, but your reputation for careful work. That matters whether you're sharing with a tight circle of fellow hunters or an audience of thousands. A find that passes your own controlled checks will always be more satisfying to present because the story is already confirmed by evidence. It shifts the focus back to the hunt in the moment of genuine success instead of the distraction of walking back an error. Testing first is a habit that defends both the accuracy of your results and how those results are received. Prospecting rewards preparation as much as persistence. By understanding how easily bias can color judgment, and by locking in consistent methods to counter it, you keep your decisions grounded no matter the setting or the audience. That steadiness improves your odds of recognizing the real thing, and it keeps your energy for the work ahead instead of on undoing avoidable missteps. Confirming before you claim doesn't dull the rush of finding gold. It ensures that when you share the news, the story holds. That's a key part of earning trust over time and of avoiding the wrong kind of attention when a find turns out to be less than it looked. And that steadiness is what makes it possible to enjoy not just the discovery, but the whole hunt as it plays out in the gold rush landscape of today. In 2025, the chase for gold is alive across rivers, tailings, and screens. The tools are faster, but the core lesson hasn't changed. Start with the streak test, then use tech carefully. Geological surveys and the USGS have recommended the streak method for generations because it gives a reliable answer regardless of surface tarnish or lighting. Enjoy the hunt, but keep your finds grounded in fact to avoid becoming the next fool's gold clip. Share your best or worst field testing story in the comments, and like or subscribe if you found this useful. Find the glint, streak it, then post it.